In section 9.4, we're going to be solving some equations, and these equations involve polynomials that are already factored. And we're going to make use of what's called the zero product property. And this tells us that if we have any two real numbers, a and b, and we multiply them together and get a product of 0, then one of those two values, a or b, has to be 0. Just think, if you multiply two numbers together and end up with 0, the only way that can ever happen is if one of those is 0. So let's see how this works in actually solving an equation. So here we have the directions solve each equation. Number one, we have x plus 4 times x minus 3 equals 0. So here the x plus 4 is equivalent to, in other words, a, and x minus 3 is equivalent to b. We're multiplying them together and getting 0. So one of those two, a or b, has to be 0. So we can write out that x plus 4 is equal to 0, or x minus 3 is equal to 0. So one of those two quantities has to be 0 in order to get a product of 0. So of course here we would subtract 4 from each side to solve for x, and we get x equals negative 4, or add 3 to each side, and we get x equals 3. So you could see this see it written x equals negative 4 or x equals 3, or you could also see it written as x equals negative 4 comma 3 to show that x can be either one of those two values. Those are both solutions to this equation. Okay, number 2, we have 3x minus 4. Again, this serves as a if you like. X plus 2 is equivalent to b. But we're multiplying two quantities together to get 0. Remember, 3x minus 4, it involves two terms, but when you go ahead and evaluate that, it really simplifies to just one quantity times a second quantity is equal to 0. And so we have 3x minus 4 is equal to 0, or x plus 2 is equal to 0. And same idea here, it's just going to involve a couple more steps here because we need to add 4 to get 3x equals 4, and then divide each side by 3 to get x equals 4/3. Or in this case we only need to subtract 2 and we're done in one step. X equals negative 2. Okay, number 3 and 4, we have a different set of directions. Here we're told to factor out the greatest common monomial factor. So here we have a binomial, and we want to factor out as much as we can from those two terms. In other words, what do they share in common? So focus first on the coefficients. You have 8 and 4. So the greatest common factor there is 4. Then look at the variables. Well, there's only a variable in the first term, not in the second, so we can't factor that out. So we're going to have 4 parentheses, and then take 8x divided by 4 will give you 2x. And then negative 4 divided by 4 gives us negative 1. Okay, so we factored out a 4, and this gives us 4 times 2x minus 1. What we're really doing is the reverse of the distributive property, and you can check your work by actually applying the distributive property again. So if you take 4 times 2x, you get 8x. 4 times negative 1 gives you negative 4, so we did our work correctly. Number 4. 12x squared plus 3x. So if we look at our coefficients 12 and 3, the greatest common factor is 3. Now look at the variable x squared and x. We can take only as many x's as we have the fewest number of in any term. So in other words, here we have 2 x's, here we only have 1. Because we only have 1 in the second term, we can only factor out 1. We can't take more than we have in any given term. So we have 3x parentheses, and then focus on coefficients. 12 divided by 3 is 4. X squared divided by x is x. So in other words, we had 2 x's, but we factored one of them out, so there's 1 left. And then 3x divided by 3x is 1. We factored out that entire term. Don't forget that still is represented by a 1 here, though. And again, you can check your work. If you take 3x times 4x, you get 12x squared. 3x times 1 gives you 3x. Now, where are we going to use that? Well, in a problem like this, for example. solve 6x squared equals 18x. And what I would suggest to you is anytime you see an equation like this that has an x squared, we generally want to get everything over to one side of our equation. So I'm going to subtract 18x from each side, and this is going to give us 6x squared minus 18x equal 2, and then we have 0. So we've got everything over to one side, other side is equal to 0. Now factor out whatever you can here. So look at the coefficients, 6 and 18. Greatest common factor is 6, and factor out as many x's as you can. Here you only have 1, so we can only take out 1. So we take 6x squared divided by 6x is x, right? 6 divided by 6 is 1, so our coefficient is 1. We had 2 x's, we factored one of them out, so we still have 1 left. Then we have minus 18 divided by 6 is 3, x divided by x is 1. So it's just x minus 3 in our parentheses there, equal to 0. Again, you can check your work. 6x times x is 6x squared. 6x times negative 3 is negative 18x. So now we have a product equal to 0. All right, so that means that either 6x has to be equal to 0 or x minus 3 has to be equal to 0. So if you divide each side by 6, you'll get x equals 0, or add 3 to each side and x will equal 3. Okay, number 6. Solve 3x times x minus 4 times x plus 4 equals 0. Well, here's an extension of the idea of having a product that's equal to 0. Even when you have 3 terms all multiplied together, the same result, one of these has to be 0. So either 3x is equal to 0, or this quantity x minus 4 is equal to 0, or our third quantity x plus 4 is equal to 0. So in this case, we divide by 3, we still get 0. So x would be equal to 0, or add 4 to each side, x would be equal to 4, or subtract 4 from each side to get x equals negative 4. All right, and finally number 7, we get a word problem. So you might have run across this in a physics class before. If not yet, hopefully you will in the future. The vertical motion model describes the height of a projectile in the form h equals negative 16t squared plus vt plus s. And what do all these variables represent? Well, h is the height at any given moment, t is the time in seconds that the object has been in the air, v is the projectile's initial vertical velocity, and the units here are feet per second, s is the projectile's initial height, where did it start height-wise, and the units are feet. Well, the question here is, if you have a machine sitting on the ground, so the height is 0, and it launches a tennis ball straight up into the air with an initial velocity of 80 feet per second, how long will it take before the ball hits the ground? Okay, so let's look at what we know. We know our initial velocity, v, is 80 feet per second. Okay, we also know that our initial height, s, is 0 because this machine is on the ground. Okay, so now we can rewrite this equation with what we know. So we have h equal to negative 16 t squared plus 80t. So v is 80, so we have 80t. And because s is 0, it drops out of our equation. How simple is that, right? Okay, so we have height is equal to negative 16t squared plus 80t. Well, we still have 2 variables and we really want 1. So now we look back at the problem and we notice, how long will it take before the ball hits the ground? In other words, h is equal to 0 at the time that we're looking for. So we have negative 16 squared plus 80t is equal to 0. So now factor out what you can here. You have a negative 16 and an 80. Notice 16 actually goes into 80. Thank goodness for that, right? So we have 16. You have 2 t's here, only 1 t there, so we can only factor out 1. And now it's common, you don't have to do this, but it's common to have that leading coefficient positive if possible. We can do that by making that a negative 16t. And then inside parentheses, So we had negative 16 divided by negative 16 is 1, so we've taken care of the coefficient. T squared divided by t still leaves us with t. And then we have plus, actually we're going to have minus there because we factored out a negative 16. So we have a positive 80t divided by negative 16t is minus 5. Okay, so we had 1t, but we factored it out, so we just have that constant, negative 5. This is equal to 0. Well, now we have a product here. So we have one quantity times the second quantity is equal to 0. That can only happen if the first quantity is 0 or the second quantity is 0. So in the first case, divide by negative 16 and we still get t equals 0, or add 5 to each side to get t equals 5. So these are the two times that the ball will be at a height of 0. At time 0, before we even launched the ball, because that's its initial position, and then at time 5. So after 5 seconds, the ball is going to hit the ground. Alright, so there you go, and good luck with solving your polynomial equations that are already in factored form.